Hello everyone, welcome to the System Engineering final presentation. My name is Xiantian Sun, and today I'm going to bring up the flight management system. The first of all is the needs analysis. Flight management system have been greatly developed as an important component of a modern airline's avionics. Flight management system is widely used on modern civilian aircraft to manage the flight plan. And the stability and the safety are always the aircraft first considered. An aircraft company trained advanced autopilot and trying to reduce costs of labor and fuel. And the next is operational analysis. The workload nowadays for the flight crew is heavy. They have to watch the fuel monitors and have to contact with the different airport and exchange information. And also the complexity of cockpit instruments is very high. And there's too many buttons and there's too many rules for the pilot to remember. Also, the system integration needs to be improved. Next, I'm going to introduce a little bit more about the flight management system. The flight management system have few components. First of all, flight management computer. Flight management computer is one of the most important subsystems of flight management system. The flight management computer is used to pre-program a large database into the system. The flight system is constantly updated with current position and automatically select the most appropriate aids during information updates. Flight management computer also runs the flight management software to manage the various functions of flight. And the next one is automatic flight system. Automatic flight system, also known as AFS, and the navigation system are two largely related subsystems in flight management system. AFS receives sensor information from navigation system, which including inertial reference system and a global position system, and then determine whether the aircraft is under autopilot or manual control. Flight crew can select different modes through AFS, either automatically move or control the aircraft flight control surfaces or display flight direct monitors from the pilot to achieve the desired status. The navigation system contains IRS, AHRS, and GPS. GPS gives the system accurate aircraft location, and IRS hand out the original data of aircraft. Navigation system send the navigation information to the flight management computer and send the important database to EFIS for display. And the next one is the electronic flight instrument system, which also known as EFIS. EFIS is used to display flight information to flight crew. It's constituted by EADI and EHSI. EFIS gathers the information such as position, speed, navigation, flight plan, and so on from flight management computer, and it displays on the screen to the flight crew. And the next one is navigation. We already talked, including the EFIS system. Then we're going to talk about the feasibility analysis. The improvement of coding generation and the validation will be the most efficient way to improve the flight management computer. And also the new technology and theory has been come out recent years. Also the cost is affordable compared to the profit. And there are many large companies such as Boeing and like American Airlines are spend huge funding from various aircraft. And the next one is needs validation. And first of all, like the new operation must be easier to study, and the pilot can easier to remember all the new rules, and which must be similar to the current rules. And also it must be affordable for the company and also the aircraft. They can update the new system together, and also it must fit various aircraft. It can be widely and used for the different aircraft, even the like small craft, civilian craft, and the business craft. The next one is concept explanation. And what I'm going to introduce like few different explanations. First of all is the four-dimension guidance. The four-dimension guidance is add a time requirement to the three-dimension position information of the aircraft. The basic concept is to accept the arrival time requirements before or during the flight, and to accurately control the flight process in order to arrive on time. To shorten the aircraft spacing, eliminate unnecessary waiting time, and improve the airport under the guarantees of safety. In order to obtain the four-dimension guidance capability, many work have been carried out aboard in recent years. When the arrival time is reached, there is only a difference of 6 seconds from the time set at the beginning. The test results show that the 4D flight management system, in addition to saving fuel, is also beneficial in reducing delays and reducing the workload of drivers and aircraft control staff. However, the scope of use of the 4D flight management system will be greatly affected by the evolution of the air traffic control system, and so far have not yet reached a particle level. And next one is improving the air traffic control environment. Improving the air traffic control environment with the fuel crisis and the saturation of air traffic field in the peak of the terminal area landing. The Airspace Control Department is required to provide system and the procedure to support the best cost of the flight and reduce the delays. The implementation of these plans will affect the work of the management system on board. Due to the improvement of the air traffic control environment, investment in huge permanent facilities is required. Also, it takes a long time for all equipment to be put into use. And also, adopting the advanced system structure, which will also cost large fundings and have like a long time to be used. And also, we can develop a system integration and change make the aircraft system more combined together and will be more efficient to use. Also, next I'm going to talk more about the modeling aircraft, which is also my concept definition. The aircraft modeling is control, object, and FMS. The aircraft model is mainly divided into a motion model and a performance model. There are many types of aircraft motion models used to describe the dynamic characteristics of aircraft motion, such as particle motion model, rigid body motion model, energy state model, small angle of attack, particle motion equation. Appropriate aircraft motion models should be used at different stages of research and development of flight management system. The performance of aircraft considered in the FMS study is mainly a series of tables and aerodynamic characteristics that characterize the aerodynamic characteristics of the aircraft. Among them, the characteristics of the lift and the drag are the most important. And the engine is the exclusive control mechanism of the flight management system and is the main source of aircraft power. The working characteristics of the engine are different in different flight stages. Different flight states such as climbing, cruising, and sliding. Therefore, the establishment of suitable engine model is required to design the thrust management system, develop the flight management system guidance law, and optimize the trajectory. Aircraft engine model is mainly includes slow train performance, thrust model, fuel flow model, and some restrictions. Modeling of atmospheric environment. The change of the atmospheric environment has a greatly influence on the performance of flight management system. It directly affects the optimization process and optimization performance of flight management system for flight trajectory. Studies have shown that changes in wind speed and wind direction will directly affect the time required to fly over a fixed distance. The temperature changes affect the magnitude of the vacuum velocity and the geometric height change rate during the climb and the decline phase. In addition, the size and direction of the wind also affect the value of the optimal cost index when optimizing the trajectory. And definitely, by using the modeling aircraft, it will reduce the pilot operation and also save the gas. Next one, I'm just going to talk about the engineering development. The analysis of the concerti. Nowadays, due to the increased complexity of cockpit instrument and gases, and to the higher degree of automation, it has become more and more difficult for pilots to understand the connections and the dependence between the numerous cockpit systems. Analysis of accidents and training sessions performed in flight simulators show that system behavior is not always as expected by the crew. Often enough, pilots are not fully aware of the functionality that is offered by flight management system pages. So the most obvious change in the user interface is the use of the graphical output device as used in today's navigation displays for user input. A graphical object-oriented user interface makes it possible to implement direct operation aspects. Because of this method, only the features that apply to the selected object are presented to the pilot. In addition, the function-oriented approach is implemented as the way used in current system, but only displays the selected function at the same time, or even more than one. The combination of object-oriented and future-oriented user interaction will increase the situation awareness of the pilot. Fewer buttons are necessary, which not only result in a large button, but also reduce the likelihood of error pressing the wrong button, and a large space can display a larger button. And also the next one is accurately control the flight process, which can be easily solved by the 4-dimension guidance as we already talked above. The next one, I'm going to continue to talk about the analysis of the uncertainty. The comprehensive level of flight management system will be further improved. Engineers describe the future flight management system as a system with a function need to solve all problems on board. From this consideration, the development of navigation guidance, flight control, flight instructions, system monitoring, and warning. Air traffic control of the future civilian aircraft will have an impact on the flight management system. For example, the advanced flight management computer developed by Spire has been used. The range of cross-linkable system and the integration has greatly improved. After crossing link with equipment involved, the system has many functions. Also, the fault-tolerant computer system architecture on the fine-grained configurable aircraft management computer is distributed primarily because of the use of factory replacement model in the general onboard computer module used. The 3-node computers from a system and the node computers are connected to each other by high-speed series bus. Each node computer is a synchronization with other node computers. When performing system tasks, Each node computer relies on high-speed serial bus to exchange data between different modules when performing system tasks. And if a failure occurs in the node computer, it will not cause the node computer to fail. And also, to meet the flight control function, strong real-time performance must be guaranteed. The core of flight control is cross-transition, which is generally in the microsecond level. So the core parameter indicators must be microsecond in the operation system. Another goal must be considered in the aircraft management computer operating system is security, whether the user program is safe under the support of the operating system and whether the security evaluation conforms to the operating system itself, the existence value of security. Okay, the next one we are going to talk about the post-development stage. First of all, the robustness of flight management system. When the emergency occurs, the flight management system can give the pilot easier way to solve the emergency. They have the function of the different system as more combined, and also by introducing to the four-dimension guidance, and also by using the engineering development we already introduced, the flight management system will be easier for the pilot to solve the emergency. And also the visibility of flight management system is also much easier. The pilot can have a large monitor, and also the push button are largely reduced, which can give them more time, more space, and also can reduce the error for the pilot. And the next one is growth capability of flight management system. As we already know, there are so many companies are spending large fundings on the flight management system. The future of the flight management system is very bright. And excuse me. And by using all the fundings, we can generate the more efficient coding, and also make the pilot easier to fly the aircraft, and also largely reduce the workload for the flight crew. And also the affordability of the flight management system is also affordable. As we already know, the large companies such as Boeing, American Airlines are spending huge fundings, so which means compared to the profit they gain, the cost is is also illegal. So which means definitely the new flight management system can be affordable. The next one we are going to talk about the challenge. The navigation device in the aircraft is controlled by multi-terminal devices, and the device configuration with redundant degrees is used. Each navigation device works independently, and there is no real-time communication of information, resulting in certain defects in the data provided by each system, and the integration is not good. The flight system monitoring must be realized through manual information comparison, which seriously hinders the efficiency of flight management. The update of flight information cannot be used to navigate the information resources in the first practice. And also, there are too many automatic flight modes, which may cause the drivers to blow or misunderstand in some modes of automatic transition. Some drivers are over automatic, resulting in blind security and the accidental loss of control. The driver relies on the automation system for a long time. In the absence of manual manipulation practice, the level of technical proficiency is gradually declining and ruined. When a certain accident occurs, they will be at a loss. high automated and to reduce the workload of the driver in the air, excessively idleness, long-term inertia, and thus loss of the vigilance. And also the functions of navigation are relatively simple, and the technical means are also backward in price, which cannot meet the diversified navigation of the current flight and the comprehensive regulation in the air. The data resources in the navigation device store less lines and information. The means of invoking data is single, unable to meet the comprehensive utilization and the control of the resources at this stage. And the multitask of flight management and the management of multi-segment in the air cannot be satisfied. And even we have like many challenges nowadays, but I believe by keeping the research on the flight management system, all the challenge can be solved, and the new and better flight management will be brought out to reduce the workload of the flight crew and reduce the cost of a flight, and also in the future will get the profit for all the aircraft company. Okay, thank you for watching the presentation.